Hello community! Today we only code. We code multi-agent system, reinforcement learning, imitation learning, but only the code. So first 5 minutes we will look at the traditional multi-agent code, and then I would love to show you two absolutely new frameworks for multi-agent coding. If you want to learn deep reinforcement learning, 224R, Stanford, beautiful. This is from Spring 2023. You have prerequisite, you have the videos, you have the timeline, you have all the materials, you have all the code, you have here Colab notebook, you have here different publications you can prepare yourself, you have homework, whatever you like, highly recommend Stanford if you want to enter here. Of course, next one is UC Berkeley, deep reinforcement learning. If you want to get familiar with this, of course, if you want to see the lecture recordings from the fall of 2023, you can watch them here, or you have here all the slides and all the information about the course from Berkeley. Beautiful. Of course, if you want, you can also go with Hugging Face. They have the deep reinforcement learning course with a lot of beautiful code implementation. You just choose whatever you want to learn, and you see here the explanation and the code. Just to show you, you have here, for example, Python notebooks where they explain it to you, they give you the overview, and then you have the explanation again. Somewhere should come the code, they have the pseudocode. So let's code our first reinforcement learning algorithm, and you see then you have here your Colab notebook, and they explain in detail what is going on and what you have to code. Highly recommend this. Or let's say you prefer OpenAI, spinning up. Welcome to Spinning Up in Deep Reinforcement Learning, user documentation, algorithm, running the experiments, launching the script, plotting the results, introduction, resources here, everything here by OpenAI. Very nice. Or you prefer here the cookbook by OpenAI, for example, quite recently, 2 days ago, structured outputs for multi-agent system. You have here a specific cookbook exactly for this, how to set up the environments, how to set up your agent. You have your code, data preprocessing agent, data analysis agent, data visualization agent, your tools that you can use. So you have a complete cookbook if you want to go in this way. Or you prefer another company, Cohere. Cohere has here, if you're not familiar with this, the LLM University. They have here different models. The last model I would recommend to you, number 8, tool use. Here you rack to tool use, single step tool use, multi-step tool use on LangChain, the full article plus the complete code available. Of course, they go with their LLM by Cohere. It really depends what you like, what you want to go with. You have here also on GitHub, Cohere AI notebooks. For example, here data analysis agent, Cohere and LangChain combination here in a Python notebook. Here you can see all the other examples that are available for you for agent learning. And they explain it very nicely. They explain here every code step in detail, how you have to code this, create a React agent, data analyst, ask the question and everything. So beautiful. You can go if you want with Cohere. Or you go with Anthropic, whatever you like, user guides, tool use, function calling. They have beautiful explanation, what is happening, how you can use agent, how you can use tools, the planning, and. Everything is available for you. Or if you prefer Microsoft, my goodness, from March 2024, building a multi-modal, multi-agent framework with Azure. And on Azure, you use an OpenAI Assist API to build your multi-agent framework. You go there, you have the explanation, and then you have the code, particular, of course, for Azure platform. If you prefer Azure, please go with this code examples. It's all up to you what you like. If you like individual course providers like Coursera, just had a look here. Look, you have here University of Alberta reinforcement learning, or IBM deep learning and reinforcement learning, or machine learning and reinforcement learning in finance. From deep learning AI, unsupervised learning, reinforcement learning, decision making, Columbia University. So whatever you like, some courses are free, some courses you have to pay. I think you just go to your preferred platform and you look for courses. Of course, if you like to have the full power of the explanation, I recommend also PyTorch, the PyTorch documentation, the official PyTorch documentation. And you see here, competitive multi-agent reinforcement learning with Torch reinforcement learning, a specific tutorial where you have here from the policy, the critique network, the replay buffer, the loss function, the trailing utilities. You have here the complete code available for you, explained in detail if you prefer directly from PyTorch, or you go here with a multi-agent reinforcement learning, a PPO with the Torch reinforcement learning. I have here another tutorial also explained in detail what is it, why we code this, what libraries do we need, environment, replay buffer, and. So you see, I think the possibilities are almost endless. Also, I would like to show you for the latest research results, paper with code. And there you go, for example, and you say metaprogramming for multi-agent collaborative frameworks, or scaling LLMs-based multi-agent collaboration, or multi-agent software development to cross-team collaboration. You have the paper and the code on GitHub available if you look for something specific. What else? Kaggle. We have Kaggle. There you have to find here the particular user. For example, here I found master reinforcement learning, a curated list of resources dedicated to reinforcement learning. And you have here books, surveys, website. Go to Kaggle, maybe you find what you're looking over there. If not, always a good idea to just go here, GitHub, you put in multi-agent in the search query, and then you get 3,300 search results from OpenAI, multi-agent, particle environments, multi-agent competition, Google DeepMind, OpenSpiel. And you see, you just look for your particular code that you want to go for your particular task that you're looking for, whether your particular Google, Microsoft, whatever you prefer, wherever you feel great. Multi-agent would be the next one. Then we have a particular, yes, thank you, GitHub here, hashtag multi-agent reinforcement learning. Here you see 160 public repository exactly only focused on multi-agent reinforcement learning. You see updated 3 weeks ago. Padding suit, a classical one, CityFlow, yes. So whatever you like for your job, this is available to you. If you prefer PyTorch Lightning, they also have here, looked it up, a multi-agent reinforcement learning with Warp Drive from Salesforce. You have here open your Colab notebook, and you have here beautiful explanation, by the way. Then they tell you what is the simulation. They tell you everything about the dependencies, and then you have the code optimized, of course, here on Salesforce. Plus, what else there is? You find also particular GitHub repos for papers. You have here, for example, the open source code base for efficient multi-agent reinforcement learning by planning. So you see, just some months ago. So look here for a particular title or a particular task you are looking for. You have the possibility to go here to Ray. They have also an RL-Lib, industry-grade reinforcement learning. They offer here environments and Ray is always also a good idea to have a look at. What else? Yeah, the classical ones, of course, here that you find is Gymnasium. This is the former OpenAI library. This is now here by Farama organization. And you have here all the classical, really classical 5 years old, 7 hours old, 2 months old. So not so bad methodologies that you can look for. Just let me go there a little bit over there. What else we have? Stable Baseline 3, another one, set of reliable implementation of reinforcement learning in PyTorch. I know a lot of my audience is operating in PyTorch, a little bit in Keras. Then we have TensorFlow and of course JAX. What else we have? Yeah, whatever you find, as I told you, whenever you have a paper and you have here this paper, you see Normally, they tell you at the end of the abstract exactly, hey, and this is our GitHub link where you can find the particular code to this particular paper. And if we go there, you have here Agent 2.0, symbolic learning enables self-evolving agents. Everything is here. We have an Apache 2 license that is beautiful 2 months ago. The overview, they explain it normally, and then you have here the installation, citation, and the code is also available for you. Great. What else? Yeah, now this is now for expert. If you want to go in JAX and you want to do a real parallelization, we will need this because if we have multiple agents, we can operate them in parallel. We have here distributed multi-agent reinforcement learning in JAX. Mava, real nice. I like JAX, but whatever you like. Then we have here JAX MAL. This is here installation quick start. Opening Colab, the notebook. We have Apache 2 license, so everything is available for you. Multi-agent reinforcement learning in JAX. They give you here the paper, baseline, installation, quick start, and the complete code. So I think whatever problem you have, there are so much code implementations out there. You just have to choose for your level of experience, for your specific task. Maybe it is a good idea to start here with the classical reinforcement learning courses, either by Berkeley or by Stanford, if you're really at the beginning. And if you are a middle expert, you know exactly what you're looking for. And I hope this gives you an idea where you can find more resources, additional resources, so you will find your perfect code base for multi-agent reinforcement learning or multi-agent imitation learning. So coming back now, the first new toolkit, and it is now called Recursive Delegation, ReDel, a toolkit for LLM-powered recursive multi-agent system, published August the 5th, 2024, so just 3 days ago for me, recording this video, University of Pennsylvania. And they have some beautiful new idea. So we have multi-agent system that we want to code, but we have a recursive definition, a recursive programming. So we can build quickly dynamic multi-agent system, and we can run the experiments on these platforms. And it offers a modular interface to create tools for agent to use, an event framework to instrument the experiments for the later analysis, a free and open source web interface to interact with and explore developer-defined system. Here you have the GitHub, ReDel, toolkit for research and developers to build, iterate on, and analyze recursive multi-agent system, visualization multi-agent system, MIT license, currently only 7 stars, but never mind, update 4 days ago. Fundamental techniques used here, we have a root agent that can autonomously break down a complex task into smaller subtasks and assign these new subtasks to newly spawned sub-agents. The sub-agent can further delegate, creating a dynamic, adaptable multi-agent network. Beautiful. This mimics, of course, organizational structure in the human enterprises, but we just want to look at the code. The primary hypothesis underlying this new toolkit is that recursive delegation allows for a more scalable and more efficient problem-solving methodology. This means this methodology should perform better on complex tasks. Here I want to give you the comparison with competing toolkits. You have here LangGraph, Llama Index, MetaGPT, and AutoGPT. And here you see that this particular toolkit says it is the only fully open source toolkit that supports dynamic multi-agent system with a rich event-driven base and web interface. And here you have the different functionality that are in detail explained in the paper. So this toolkit now integrates various component tools, custom Python functions that agents can invoke to perform specific tasks, delegation schemes, strategy for the task delegation among the agents, allowing here for either a parallel or a sequential task execution, and an event-driven logging, captures here the system-wide events for detailed analysis, for debugging, and the performance optimization. The strength of this methodology is definitely here a dynamic task delegation, allow here the customization of our tools, and we can build our own delegation schemes. It is open source, real nice. Weakness, increased complexity. Debugging the system if you have a lot of agents is not that easy, and most important, it relies here on the design of the delegation logic to avoid inefficient task handling. And you will see we have to use here the most powerful vision language model and large language model. Example here of a simple tool that exposes here a get function to any other agent, or we have here define a custom event and dispatch it from a tool. Plus, for example, here define a custom delegation scheme. But you see the code is rather simple, but we have Kani. So we have to touch on Kani. Also here a list of events built into the toolkit. Kani. So let's talk in a second about Kani. I just want to show you here the overall performance. So get a feeling how good is this new toolkit. As you see, we have 3 different benchmarks with sub-benchmarks. We have here GPT-4 Omni and GPT 3.5 Turbo here as our main LLM. And you see the jump from 3.5 Turbo to Omni has some significant performance increase. But if you look here at the baseline GPT-4 Omni, you see, let's say these are 65%. This just jumps to 68.7%. But in other tasks, it increases from 50% to 67%. So it has a real impressive benchmark performance, but of course we have to test it for several weeks in the real world examples. But in general, this recursive delegation framework, given here the equilibrium between here the complexity that the system can build autonomously and the, let's say, compute performance and the money that we want to invest into this system are, of course, limitation factors. But in general, it should enhance our problem-solving capabilities of multi-agent system. I will try out in the next day to work on a very narrow domain. So I do not need GPT-4 Omni. Hopefully, if you work only in medicine or only in physics or only in finance, that you need here the complete multi-domain knowledge of GPT-4 Omni. But maybe we can train smaller LLMs, much smaller LLMs, on a very narrow domain to perform exactly here those problem-solving capabilities in multi-agent system. But I guess this will be a video in about 1 or multiple weeks' time. Looks promising. First 2-3 days. A new multi-agent system, recursive delegation, a robust framework for exploring more complex and more dynamic system configuration, potentially leading to some innovation. Think about this. I have here a video where I showed you we have DSPy here, our programmable, if you want, prompt engineering at the very beginning. Then we had DSPy, and now we have TextGrad from Stanford. This automatic differentiation via text here. And if you think about this now or if you transfer the idea now to a multi-agent system configuration, how this exactly agent definition and how the complete system configuration of all those agents are, if this new framework can provide here an optimization, it is itself, of course, an optimization problem, then this would be really helpful. If you go in ReDel here, you see that under Canis we have here the default root prompt, the default delegate prompt, and you have all the code available for you. If you're not familiar with for Kani for Migraine Grasshopper, September 2023, also University of Pennsylvania, LLM applications are becoming increasingly popular and complex, including features like tool usage and retrieval augmentation. Existing framework for such applications are often opinionated, deciding for developers how their prompts ought to be formatted and imposing limitation on customizability and reproducibility. To solve this, they develop Kani, a lightweight, flexible, model-agnostic, open-source framework for building LLM application. Real nice. We have the complete code. This is here the GitHub. highly hackable micro framework for chat-based language model with tool use, function calling, more than a year old, but real nice MIT license. Have a look at the code. Real nice. As you see, Python 100%. A Kani object consists, if you want, of three main parts. We have the inference engine, the underlying LLM or the associated framework. We have a chat history, simply the state of the conversation, including here the system prompts. And we have the function context. This is a list of available callable function, if any. To initialize this, it's all you need is to pass an inference engine. This is all. You see, Kani, OpenAI engine, for example, chat in terminal AI. That's it, as simple can be. A Kani object does the following three things. It interfaces with your defined models. So Kani queries your LLMs via inference engines, allowing developers to swap models without editing the application. It manages the chat history. Kani tracks the token count and turns of the conversation, ensuring that models never exceed their context. And it exposes and calls function. Kani exposes function to models, validates the function calls, runs the code, and returns output back to the inference engine. Propagates all errors back to the model to allow for an auto retrying of failed function calls, ensuring that such calls are robustly implemented. You see here in the visualization exactly where it is located. There are two ways to create Kani with function calling capabilities. You have it statically and you have it function dynamically passing them in a list to the Kani constructor. And just to show you here from the original publication from Kani, they have here the size, compare it now with LangChain, and the dependencies, compare this to LangChain. And then they have some functionalities of Kani. And if you compare this to LangChain, you see why Kani is currently a nice framework. But of course, there's also another brand new multi-agent, and this is here published end of July 2024, Alibaba Group, very large scale multi-agent simulation in AgentScope. Now this is real similar from the methodology, but it is based on another platform. Fundamental concept is simply enhance large-scale multi-agent simulations, and we are talking here about multiple hundred agents, thousands of agents. So we care about scalability, efficiency, agent diversity, and we need a web-based interface and AgentScope manager. This is managing and monitoring a large number of agents distributed across different devices with a beautiful interface. Our mechanisms are at first an actor-based distributed mechanisms, serves here as the tech infrastructure supporting parallel execution of the agents, and it uses here a communication graph to dynamically identify which agents can be executed in parallel dependent on their internal dependencies. Centralized workflow orchestration. We have here a concept called a placeholder is introduced to manage the sequential execution at the central node while maintaining parallel execution in the distributed agents. The environment in which the agent operate are abstracted into different layers for a high-frequency interaction. The background of each agent is automatically generated if you want. You can also use a configurable tool that allows you to use it to define the distribution of various characteristics. And also you have a management interface, a web-based management interface. Here you see the exact definition about AgentScope. What is it? Key concept, code structure, installation, modeling, streaming, prompt engineering. We have here the complete API references for all subpackages, beautiful. And of course, we have our GitHub. Start building LLM-empowered multi-agent application in an easier way. Agent, multi-agent, multi-modal, distributed agents, LLMs, LLM agent, GPT-4 Omni. We have an Apache 2 license. And as you can see, was updated just 2 days ago. So real nice ongoing work. Have a look at this. Maybe you would prefer this, but of course, remember the other was here Penn University, and here we have ModelScope. So here you have it, AgentScope. Start building LLM-empowered multi-agent application in an easier way. whatever you need to know here about our GitHub repo, code is available for you. Python 76%, JavaScript, HTML, CSS, Shell, beautiful. Of course, this is a model here by ModelScope, a Chinese company, and if you look here at their homepage, fast forwarding AI development with open source community elements. And this is nice because if you look here, we have an Apache 2 license, as I told you. So real nice. Show you the models, show you the dataset, the studios, already the Flux implementation, QN2, of course, Mat Instruct. So if you're interested to go here with this model for our multi-agent coding reinforcement learning, maybe you prefer ModelScope. So I think I have given you quite an overview. Whatever you want to choose, the code is available for you. Whatever you feel comfortable, whatever you say, hey, I would like to try this. This speaks to me. I like the way they code. Follow this route. Go with the code that you prefer because, believe me, it will be a long journey. So there you have it. Multi-agent code in all available forms. The classical code, complete new code implementation just 2-3 days ago. So I guess you have a big portfolio, a huge portfolio of code implementation that you can choose for your particular code. Would be great to see you in my next video.